Example 2, we are given a nice pretty little graph here, and it says we refer to the graph at the left. Nobody knows their left from the right anymore these days. Jeez, I'm going to talk to my secretary. Refer to the graph at the right, which shows data on the fastest growing restaurant chain in the U.S., possibly Jimmy John's, because they're so fast you'll freak. Find the rate of change in the number of stores from 2001 to 2006. So in 2001, now remember this is in thousands, so 2001, it's right here. And 2006, all the way up here. So these don't go exactly on the 5, so I'm going to say this is probably closer to a 6. This is probably closer to 33, we'll say maybe. And so what we're going to do is we have to keep in mind this is our x-axis, this is our y-axis. So when we find our change, our rate of change, we're doing our change in our y's over our change of our x's. So that means we're doing our change in our number of stores over the change in your number of years, or the change in years. So let's take our number of stores. So we're going to go from a 33 minus 6, and we're going to divide that by, well, 2006. So you can either say 2006, you can plug in 2001, or just 6. Regardless, we're going to end up getting a 5 on the bottom if you use 2006 and 2001, or if you just use 6 and 1. So that means, whoops, that's kind of weird looking. So if you get a 5 on the bottom, and on top, that's going to give you a 27. So if you simplify 27 over 5, that's going to give you a total of 5.4. Now what does that mean? Well, that means this is 5.4 thousand stores. 1,000 stores per 5 years. Okay, or sorry, per year, because we reduced that to be over 1. So that's going to be 5.4 thousand years. So if you multiply the 5.4 times 1,000, there are 3 zeros in 1,000. You multiply that, that gives you 5,400 stores per year. So that is quite an increase. Jimmy John's is doing good. Doing real good. I mean real well. Real good well.